Download this code from codegive.com, link in the description below. OK, let's dive into smart data storage in Unreal Engine 5 Blueprints, a powerful method for managing and accessing game data efficiently. This tutorial will cover the concepts, techniques, and code examples you'll need to implement a robust smart data storage system within your blueprint-driven projects. Introduction: the need for smart data storage. In game development, managing data is crucial. Games often deal with complex information such as character stats, health, mana, attack power, defense, etc. Item properties, damage, value, weight, durability. Level information, enemy spawns, object placements, etc. Player progress, unlock skills, completed quests, inventory. Configuration settings, graphics options, controls, sound volume. Using simple variables scattered throughout your blueprints is rarely a scalable or maintainable solution. This is where smart data storage comes in. The goal of smart data storage is to 1. Centralize data, keep all relevant data in one or a small number of well-organized locations. 2. Abstract data access, provide a consistent and easily understood way to access and modify data. 3. Encapsulate logic, hide the details of data storage and retrieval behind a clean interface. 4. Enhance maintainability, make it easier to change data structures or storage methods without breaking the entire game. 5. Promote reusability, design data storage in a way that can be reused across multiple parts of the game. 2. Key concepts and techniques. Here are the core concepts we'll be using. Data structures, structs, structures, and data tables. Data management, game instance, game state, player state, for different scopes. Data access, functions, blueprint callable, blueprint pure. Interfaces, to define standardized data access contracts. Delegates, to signal data changes. 3. Choosing a data structure. Structs, structures are custom data types that group together related variables of different types. They are lightweight and efficient for organizing small amounts of related data. Think of a struct as a container for variables. Example, a struct for character stats. A struct, blueprint type, makes the struct accessible in blueprints. Generated _body, required for USDRUCTs. A property, declares properties within the struct. Edit defaults only allows you to set the default values in the editor. Blueprint read-write allows you to read and write to the properties in blueprints. Category organizes properties within the editor. Data tables. Data tables are spreadsheet-like structures within the Unreal Editor that allow you to define collections of data. They are perfect for storing large amounts of similar data, such as item definitions, enemy types, or dialogue lines. Data tables are usually based on a struct, where each row in the table is an instance of the struct. Example, a data table for item definitions using a f-item data struct. You would create a data table asset in the Unreal Editor, choose f-item data as the row struct, and then populate the table with item information. 4. Data management, choosing a storage location. Where you store your data depends on its scope and lifetime. Game instance, stores data that persists throughout the entire game session, across level transitions. Good for global settings, player profiles, save/load functionality. Game state, stores data that is relevant to the current game session. This is replicated to all clients in a multiplayer game. Good for game time, score, current level information. Asterisk player state asterisk stores data specific to each player in a multiplayer game. Replicated to all clients. Good for player score, character selection. Asterisk game mode asterisk stores rules of the game, as well as helper methods for things like spawning and what pawn class to use. Server only. Asterisk actor/component variables asterisk for data specific to a single actor or component. V. Implementation steps, blueprint focus. Let's walk through an example of storing and accessing player data using a data table and the game instance. Step 1. Define the data structure, struct. 1. Create a new C++ class. Make sure to inherit from ue5 so we can easily create a blueprint type. 2. In the header, .h, file, create your struct. This is what will hold the data for each row of your data table. 3. Recompile. Step 2, create the data table asset. 1. In the content browser, right-click and choose miscellaneous data table. 2. When prompted to choose a row struct, select the f-item data struct you just created. 3. Name the data table something meaningful, example dt_items. 4. Open the data table asset. 5. Add rows to the table and populate them with item data, item ID, item name, item description, icon, value. The item ID will be the name of the row, make sure these are unique. Asterisk right-click on the row name to rename it. Asterisk double-click cells to edit the data. Step 3, create the game instance. 1. Create a new C++ class and inherit from ugame instance. This is where we will store the data table. 2. In the header, .h, file. 3. In the implementation, .cpp, file, let's add the logic to get the item data. 4. Create a blueprint class and set the parent class to the C++ game instance. 5. In the project settings, change the game instance class under maps and modes to the blueprint game instance. 6. In the blueprint game instance, set the item database variable to the dt_items data table you created earlier. Step 4, accessing the data in blueprints. 1. Get a reference to the game instance. Use the getGameInstance node in any blueprint where you need access to the item data. 2. Cast to your custom game instance class. Use a cast to myGameInstance node, or whatever you named your game instance class. 3. Call the getItemData function. Pass in the item ID, fname, of the item you want to retrieve. 4. Access the data in the returned f-item-data struct. You can now access the item name, item description, icon, and value properties of the item. Blueprint example, in an actor's event graph. Step 5, modifying data, less common with data tables, but possible. Modifying data directly within a data table from blueprints is generally not recommended for gameplay logic. Data tables are better suited for storing static or semi-static data. If you need to modify data at runtime, consider using a separate data structure, example AT_map in your game instance, that stores editable copies of the data table information. 6. Interfaces for data access, optional but recommended. Interfaces provide a standardized way to access data from different objects, even if those objects are of different classes. This is especially useful when you want to interact with multiple types of objects that all share a common data requirement, example all items need to have a name and a description. 1. Create a blueprint interface * right-click in the content browser and choose blueprint-interface. Name it something like BPI_itemData. 2. Add a function to the interface * double-click the interface to open the interface editor. Add a new function, example get item data, and define its outputs, example an f item data struct. 3. Implement the interface in your actors/components *, select the actor or component you want to implement the interface on. In the Details panel, under the Interfaces section, click the plus button and choose the BPI_item data interface. 4. Implement the interface functions *. You'll now have new events in your event graph for each function in the interface, example event get item data. Implement the logic to retrieve the appropriate item data for that actor/component within these events. 5. Access the data through the interface * instead of casting to specific actor/component classes. You can now use the call function node and select the function from your interface, example get item data. The engine will automatically call the correct implementation based on the object you are targeting. 7. Delegates for data change notification, optional. Delegates are a powerful mechanism for notifying other objects when data changes. This is useful for updating UI elements, triggering gameplay events, or synchronizing data across multiple systems. 1. Declare a delegate in your game instance, C++. 2. Implement the data update logic *. 3. Bind to the delegate in blueprints * in any blueprint that needs to know when item data changes, get a reference to the game instance, cast to your custom game instance class, and use the assign node associated with the onItemDataChanged delegate. Connect the output of the assign node to a custom event that will be triggered whenever the delegate is broadcast. 8. Code example, complete, item data, game instance, accessing in an actor. Item data.h*. MyGameInstance.h*. MyGameInstance.cpp*. Example actor blueprint, accessing data. See the blueprint graph example earlier in the document. 9. Advanced considerations. Asynchronous loading for large data tables, consider loading them asynchronously to avoid hitching the game thread. Soft object references use tsoft object ptr to hold references to assets in your data tables, example textures or meshes. This allows the engine to unload assets that are not currently in use, saving memory. Custom editor tools create custom editor tools to make it easier to manage and edit your data tables. Data validation implement checks to ensure that your data is valid. For example, you could check that item IDs are unique or that values are within a certain range. Conclusion. Smart data storage is a critical aspect of game development. By centralizing, abstracting, and encapsulating your data, you can create more maintainable, scalable, and robust games. This tutorial has covered the fundamental techniques, providing you with a solid foundation for building your own smart data storage solutions in Unreal Engine 5 blueprints. Remember to experiment and adapt these techniques to suit the specific needs of your project. Good luck.